Okay, so we kind of have the black bars on the side, but that's fine. Okay, so let's go ahead and get started. So a scale drawing or model is used to represent an object that is too big or too small to be shown with its actual size. So do we know of some things that have scales? Not like getting on a scale and weighing yourself. I'm talking about a measurement scale. What do we know? What are some things that have scales? Yes? Okay, yes. On like, I'm thinking about like paper. But yes, we can measure things within like teaspoons. But do you know what I'm talking about with these scales? The first hour I had no idea.
Yeah, I don't really know.
Like a map, right? So, but here's the thing, I don't think you guys look at mini maps anymore. So that's why I think first hour was confused. So a map has a scale. So down at the bottom it'll say like 1 inch corresponds to 20 miles in the real world. That's what a scale is. Or like blueprints. But I know how often are we looking at blueprints. So that's what we're going to talk about today. Scales that are on maps, blueprints, things like that. Okay? So a scale is a ratio. So that's our first break. The scale is the ratio of the size of the model to its actual size. So this is another ratio. Hopefully you're catching on. This whole unit is going to be those fractions, those ratios. So the way that we set up a scale is we put the model on top over the actual on bottom. So the model size, which will be like the smaller one, and then the actual size on the bottom. Okay, so like whatever, if we're having a blueprint of a house, the blueprint will be our model. The actual house will be on the bottom of the fraction, okay? So a scale can have the same or different units, and we can use a scale to find a missing measure, okay? So we have the scale of a drawing for a new pool is 2 inches equals 7 feet. So all of our problems are going to look very similar to this, where we need to identify what the scale is. And so what we're looking for is something that looks like that. 2 inches equals 7 feet. So that's saying, I'm assuming we have a blueprint, right, of the pool, or you can think of it as like a map of the pool. We're going to say 2 inches, that's the model, right, 2 inches over 7 feet. So that's how we're going to convert my scale, and that's how it will always look. It'll say 2 inches equals 7 feet. That's a scale, okay? We convert that into a ratio, which remember is a fraction. We're going to set up a proportion to help us solve. So if 2 inches corresponds to 7 feet, we want to find the length of the pool. If the length of the pool in the drawing is 10 inches, I want to know what is the actual length of the pool. So here's where we have to be picky. I had my units as inches over feet. So when I set up my next fraction, I also need inches over feet. And so I'm given the length in 10 inches, so I need to put that number on top. I'm finding the actual length of the pool, which is the feet. So I'm going to put my X there. So what we're doing is we're setting up a proportion. You have to have a variable, and then the other number that it gives you goes on the other part of the fraction. And so now we saw we can cross multiply, or this one is an easier one. If we notice 2 does go into 10, so 2 times what gives me 10? What am I? Times 5, right? So we can use that shortcut if you want, or you can cross multiply. So yeah, 7 times 5, that means 35 feet is how long the actual pool is, okay? So that's what we're doing. We're using the scale that it tells me. It says 2 inches means 7 feet. So then 10 inches would mean 35 feet, okay? So that's what we're doing. So number 2, let's try that one. It tells me the blueprint for a house uses the scale 1.5 inches equals 2 feet. So step 1 is identifying the scale, writing that down as my fraction. So 1.5 inches over 2 feet. We're going to set that equal to my next fraction. And we are saying the living room is 18 feet long. We want to find the length on the blueprint. So is the living room the model size or the actual size? The actual size, right? It's actually 18 feet long. I want to find the model, which is the blueprint, okay? So 18 feet is going to go on the bottom. I want to keep those units consistent, right? I'm trying to find the blueprint size, and that is in inches, okay? So if we want, we can use the shortcut method again. So I can go from 2 to 18 by doing what? What am I scaling up that fraction by? Times 9, yeah. So I'm multiplying that fraction by 9. So then I would also have to multiply 1.5 times 9, which gives me 13.5 inches when we type that in. If you don't like that method and that's confusing to you, you can always cross multiply, but I am showing both ways just so we know there's multiple options. Make sure you're also answering with your unit, 13.5 inches. Okay, so number 3, a model of a car uses the scale 2 1/4 inches equals 3 feet. If the model is 14 inches long, what is the actual length? So first thing again is locate that scale. So I'm not even caring about what the other numbers are. I just want to find the scale. So the scale is 2 1/4. This is where it gets kind of interesting. I know that most of us are probably using our calculators to do this math. So what I recommend is not using 1/4 in your fraction because we're not really good at typing those fractions into the calculators. What I recommend is converting that fraction into a decimal because then it kind of looks like number 2, right? Where I had 1.5. We can type that in. So does anyone know what 1/4 is as a decimal? Yes, Brody? 0.25. Good. So if I have 2 1/4, the decimal version of that would be 2.25. Now, if you didn't know what 1/4 was as a decimal, you can always type in 1 divided by 4. Type that fraction in. That will convert it to a decimal. It would tell you 0.25. So 2 1/4 is really 2.25 inches over 3 feet. So there's my scale. 2.25 inches over 3 feet. And so now it tells me the model is 14 inches long. I want to know the actual length of the car. So again, I want to keep my units consistent. It tells me the model is 14 inches. So I'm going to keep the inches on top. That is the model size. I want to know the actual length of the car. So I'm going to put my X on the bottom. It's always model over actual. And then here I would cross multiply. I feel like I don't know what 2.25 times to get me 14. I don't know that. So I would cross multiply. So we have 2.25 times X. That's what's in this circle right here. And then I also have 3 times 14, which that gives me, when we type that in, 42. Good. And then we can divide. So then you would type in divide by 2.25, which is why I recommend converting it to a decimal, because that would be really annoying to type in 2 1/4 into the calculator. So I would go to a decimal there. So we can say 18.67. We can say 18.7, depending on how you round. But we want our unit of feet there. Okay. So that's really about as complicated as it gets. Let's try another one with the fraction, and then you'll try one on your own. And then number 6 is kind of tricky. You're more than welcome to attempt it, but we'll do that one together as well. So number 4, it says the scale on a map reads 2 inches equals 125 miles. 2 inches equals 125 miles. So step 1, I'm not looking at anything else. I'm just going to write my scale down because that's what I'm using. 2 inches is 125 miles on this map. So it tells me 2 cities are 4 3/4 inches apart on the map. What is their actual distance? So my question is, what is their actual distance? That means I need to put my X on the bottom. And then it gives me their map distance, which is the model. So 4 3/4 inches. So yes, I'm keeping that on top. We're keeping the units consistent. Okay. So what about 3/4? What is 3/4 as a decimal? Does anyone know? 0.75. Good. If you didn't know that, then you can do 3 divided by 4 into your calculator, and that would convert that fraction to a decimal. But those are important decimals to know. That's like quarters, right? We should know 25 cents, 50 cents, 75 cents, $1. That's what that is, okay? So then I would cross multiply again, right? That's probably going to be the easiest method here. We can't do the shortcut. So we have this first circle in red up here, 2 times X. So there's 2X. And then my other circle is 125 times 4.75, which when we type that in, we get 593.75 when I type in 125 times 4.75. So then we can divide to solve for X. So I'll divide by 2, and I get X equals 296.875. Okay, miles. So go ahead and try number 5. You will get another decimal for this one, so go ahead and set up your scale. Cross multiply if you need to. I think you will need to, and get your answer. I noticed a lot of people, because the 197 was listed first, people wanted to write that right away. But remember, the scale has to go first. So the scale is 5 inches equals 40 feet. Whatever's with the equal sign, you have to keep those numbers together. So 5 inches over 40 feet. They have to be together. That's the scale. Then we look at the wingspan of my airplane is 197 feet, right? That's the larger unit. 197 feet is big. So that's my actual distance that goes on the bottom. The X goes on the top because I want to know what is the wingspan of the model. Model is what I'm trying to find, so I put my X there. So you should have gotten 24.625 inches as your answer.
Should you round up?
You can if you want. If you want to round up to like 24.7, that's fine. I just gave the whole decimal. Okay, number 6. This one's kind of tricky, but we'll start off with the scale. What does it tell me the scale of the model for this building is?
Would it be 3 over 20?
Good. So that's always step 1. Find the scale. 3 inches over 20 feet. Okay, and I'm setting that up equal to another fraction. Here's the question. It tells me the model is 5 feet tall. I want to know how tall the actual building is. So that's the model number I'm given. Does the model number go on the top or does it go on the bottom? The top. Model goes on top. But here's where it's weird. I'm given the model in terms of feet, but my scale is in inches. But that's because it's probably talking about a model building. Have we seen those? Maybe like those big Lego buildings or the big like popsicle stand sticks. Like, that's what we're talking about. So it's going to be a large building, but the actual building is going to be even bigger, okay? So what can I do? I need to convert 5 feet into inches because I need to have consistent inches. So what do we know? How many inches are in 1 foot? 12. So we can say 5 times 12 will give me 60 inches. So really, the model is 60 inches. So that one was intentionally written like that to throw us off, okay? So we're talking about the model. The model has to go on top, but we have to have the same units of what my model was in. It's just giving me it in a different unit I had to convert, okay? And then I put the X on the bottom. So that one was kind of tricky. There'll be one like that on the homework that you really need to pay attention to the wording because it's kind of weird. So then we can cross multiply, or you can use your shortcut. I can use my shortcut here. 3 times what gives me 60? What am I multiplying that 3 by?
20.
By 20. So if you caught that, great. You can multiply the 20 by 20 on the bottom to get 400 feet. So, and that makes sense, right? We're talking about a big building, 400 feet. If you flipped it around and you put the 5 on the bottom, you would have gotten a really weird answer, and it would not have made sense. Okay, so that's going to be number 6. That one was kind of tricky there. Most of them won't be like that, though. Okay, so number 7 and 8 are going back to normal. There's no tricks. You can just kind of follow the order there. So 7 and 8, I want you to try on your own. We're not going to do 9 and 10 at that point. They're just kind of repeating. So we're just going to do 2 more. I'll help you set up number 8, though, because notice we have a lot of weird fractions. So I'll help you set up number 8, but I want you to finish it, and I want you to finish number 7 as well. So number 8, it says a map of Texas uses a scale of 1.5 inches to 40 miles. So I'm going to highlight my scale, and I'm going to start there. 1.5 inches. How do we know we can write 1/2 as a decimal? What is 1/2 as a decimal?
Oh, 1/2? 0.5.
0.5. So this is really 1.5 inches to 40 miles, okay? So there's my scale. 1.5 is really 1.5 inches over 40 miles. It tells me Houston and Dallas are 8 and 7/16 inches apart on the map. We want to find the actual round trip distance between them. So I know the model distance. I'm trying to find the actual distance. So because I'm trying to find the actual, I can put the X on the bottom. That's where the actual goes. The 8 and 7/16 is going to go on the top. 7/16 is a weird fraction. I don't even know that off the top of my head. So I would type that in. 7 divided by 16, and we'll see what that decimal is.
0.43.
Good. 0.4. I would keep it all here just so we can be really, really accurate. It should be 0.4375. I would keep it all. We want to keep that decimal as accurate as possible to the fraction. So 8.4375 is really what we can type in. So that way I'm not typing in that weird fraction to the calculator. Okay? So go ahead and set up number 7. So I checked most people. We look pretty good. One thing I noticed is maybe we just accidentally flipped the order. So this one was kind of weird because we're talking about 2 different paintings, but the smaller painting or the model painting is what we're trying to find. So my X is going to go on top. The actual painting is 6 feet tall. That's the big thing. That's the actual size. So that's going to go on the bottom. So that's how you set up the first one. We set up the second one. Your answer should have been 225. If you didn't get that, I would go through and cross multiply again, okay? But we set that one up together. So that's it for finding a missing length, okay? I'm given the scale. I'm going to find a missing length to one of the 2, right? I need the model length or I need the actual length. We also have a couple problems where I have to be the one to find the scale, okay? Where I'm given 2 distances or 2 lengths, and I want to figure out, well, what is one of the model length correspond to with my actual length, okay? So we have 2 steps here. The first thing we're going to do is we want to write the ratio of the model to the actual. So that is the same thing that we had before. So we're going to start it the same way. Model size over the actual size. That stays the same, okay? So the model size for number 11 is the drawing length, okay? So the picture, the blueprint, the drawing, all of those are the same things. They're all models. So we can say 9 inches is going to go on top over the actual length of whatever it is we're drawing is going to be 45 feet. So this is my scale, but what I want to do is I want to reduce this scale. You can almost think of it as like the unit rate, but for scales, okay? So it's almost like the unit rate, but for scales. So what I want to do is it's like, okay, cool, 9 inches corresponds to 45 feet, but that doesn't really tell me too much. It would be nicer if I knew how much 1 inch, 1 unit of my model, how much does that correspond with to the actual distance? So here's what we can do. I want to reduce the numerator to 1. I want to simplify. I want to reduce this down. So what can I do to this 9? How can I turn a 9 into a 1 by multiplying or dividing? Dividing by 9. Good. So what we're doing is we're going to simply divide the numerator and the denominator by whatever your numerator is. Because I'm trying to get the numerator 1. So if I divide by 9 on the top and I divide by 9 on the bottom, this is just reducing the fraction, right? We've done this before. But we're reducing it with a purpose. We always want my numerator to be 1. So 9 divided by 9 tells me 1 inch. And then we could type in 45 divided by 9, or hopefully we know that it's 5. So there is my scale. That's what you want. You want to try to get to saying 1 inch really means 5 feet. Yes?
So what happens if you can't divide by your numerator by your denominator?
You still do. You just make it decimals. So if it doesn't go into it as a whole number, that's fine, because that's what's going to happen with number 12. So let's try that again. My model length is 6 2/5 meters. So 2/5, let's try to write that as a decimal, right? We could type in 2 divided by 5. That gives me 0.4. Good. So my model length is 6.4 meters over the actual length is 120 kilometers. And again, my goal is to just get a numerator of 1. I want to know how much 1 meter corresponds with the kilometers. So what do I need to divide by to get the numerator to 1? What is my numerator? That's 6.4. So I have to divide by 6.4. So whatever your top number is whatever you're dividing both the top and the bottom by. We're reducing it. Okay, so 6.4 divided by 6.4 gives me 1. And this is where you definitely will need to type that in. 120 divided by 6.4 gives me 18.75 kilometers. That is fine. You can have a decimal there because it's a scale. So we're saying 1 meter corresponds to 18.75 kilometers. We're just reducing this scale down. We're almost making it like a unit rate where we were just 1 of something. Okay, I'm going to try number 14 with you, and then you'll try number 13, okay, because I want to do another fraction one. So 14, it says my cell phone tower is 162 feet tall. That is the actual size of that tower, right? That's a large height. So we're going to put the 162 feet on the bottom. It tells me the model is 5 5/8 inches tall. So that's going to go on the top. So 5 point something, because I need to convert 5/8 into a decimal. So we can say 5 divided by 8, which gives me 0.625. So that's how we can convert 5/8 into the decimal. 5.625 inches. Okay? So then here's what I'm doing. I want to reduce that numerator to 1. I want to say 1 inch means how many feet? So I can divide both the top and bottom by 5.625. Whatever the numerator is what we divide by. So 5.625 divided by 5.625 gives me 1 inch, which corresponds to, and then we can type in 162 divided by 5.625. That gives me 28.8 feet. So there is my scale. 1 inch is 28.8 feet. Okay, so go ahead and try 13, and then we'll come around and give the homework, and that's it. Okay.